So today we're going to be discussing Hooke's law and how to prove it using a practical. So here's the setup. We have some string or a wire and we're trying to determine the spring constant of this string. So first of all what we do is we simply measure the original length of the string. And we do that with this meter rule that we have now clamped on to this clamp stand. And then what you're going to do is you're going to add some mass onto uh, onto the string. And what you're going to see is the string is going to extend. So you're going to first of all add a known mass to the string. And what you're going to do is you're going to measure the new length. So with this, you can now calculate the extension, which is simply the new length minus the original length. And you're going to repeat this with more masses. So you can add on more known masses, calculate the new length, work out the extension. What you need to make sure that you do after each measurement is to deload the mass from the string. Make sure the string returns to its original length, and then reload with the new mass. So you deload it, make sure it goes back to its old length, and then add your new mass on and measure the new length, and then you can calculate your extension. So you can now create a table with all the masses that you've used in kilograms. And because this mass is exerting a downwards force on the string, it's going to result in a tension in the string, which is equal to the weight of each mass. And this will simply be the mass times gravity. So for each, let's say you had 0.1 kilograms added on at the start, this would be 0.1 times the gravitational constant, which is 9.81. And then you want to note down your extension values in meters. So what you can do is you can now plot a graph with force on the y-axis, which is going to be your weight, and you can plot extension on the x-axis. And you should see that if you draw a graph, you'll get a graph that has a straight line and goes through the origin. And this here shows that the force on the wire or the string is directly proportional to its extension. And you can convert from a proportional sign to an equal sign by simply adding a constant. So you can now say that the force is equal to kx. And this is Hooke's law. And k here is your spring constant in newtons per meter. Now, just as a quick side note, you could also plot a force versus length graph, where instead of calculating the extension of the wire, you could just simply use the length that you measured. And this time you'll also get a straight line, but it won't go through the origin. This here will be your original length. Now, the spring constant may also be referred to as a spring stiffness. And let's say I had a lot of force versus extension graphs for several different wires. And let's say they all look something like this. This is wire 1, wire 2, wire 3. Here, wire 1 has the highest spring constant. And that's because you know that F is equal to Kx, and in this case, K is your gradient, and wire number 1 has the largest gradient, so it must have the highest spring constant. And what the spring constant actually means is that it's the force required to extend the wire or string or the material by 1 meter. So you can see here that string number 1 would require a lot more force to extend it by the same amount as the other two strings. So that means that in this case, wire 1 would have the highest spring constant. Now, the best piece of advice I can give you after watching that video is to go off and practice on past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.